Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. A couple things before we get started today. Obviously, we have a Discord now. There is a button for it. If you would like to chat offline as well as online, you can always go over there. It's Discord for all Molly Rocket things, including Handmade Hero. And there's pretty much people chatting at all hours of the day on there. So head over there. There's a technical area to ask tech questions or talk about tech stuff. There's also a general place. There's an art place. There's even a place for food. People have been doing so much handmade cooking. There's like a food channel on there now. So head over there if you want to check that out. I also have a public service announcement. The watch page is broken. I mentioned this the other day. I double checked it. Twitch went ahead and changed their API out from under everyone, as they love to do. And so I'm gonna have to go re-implement the thing that asks Twitch whether the stream is live, because of course, it was too much to ask for them to have the question about the stream being live be something that they could support in multiple versions. That was just way beyond anyone's technical capabilities at Twitch. They just couldn't imagine how something like that would occur. And so, I get to go rewrite that part of the code, and so that'll be a lot of fun. Thanks, Twitch, for that. Moving on. Today we've got some debugging to do. We left yesterday. We had done a bunch of work to set ourselves up for doing light probe calculations and sampling from light probes inside the actual game proper. I'd like to get to that. But before we do, we have a bug that we want to solve, which is that, I guess we don't really know it's a bug, but my assertions that I put in the code are triggering, and so unless those assertions themselves are somehow wrong, which I don't think they are, but I don't know, we'll have to double check. Unless those assertions themselves are somehow wrong, we have a bug in the system that assigns light probe IDs to light probe entities. And the reason that we have this at all, because, you might be asking why do we care? It's a legitimate question. The reason we care is because in lighting, we do not have the luxury of largesse, basically. When we are processing lighting, it is going to be very difficult and performance critical. It's going to be hard for us to optimize it to a speed that we are going to be happy with, because lighting is just very expensive. That's why they're shipping graphics cards that specially accelerate ray tracing, right? Lighting is hard. Lighting is the hardest thing you can possibly do in computer graphics. Well, all right. Yeah, maybe it's not the hardest thing you can do. Maybe we could argue that motion blur is actually the hardest thing you can do if you want to get it right. But, let's just say that short of accurate motion blur, lighting is the hardest thing. And let's be frank, if you were going to have to do accurate motion blur, you would need to light the motion blur accurately, and then we're back to lighting. Anyway, it's one of the hardest things you can possibly do, let's say that. And so we don't want to have large numbers of extra light probes sitting around in the light probe system, getting calculated, wasting CPU cycles. We don't really want to have that. We want a nice, tight, compact array of only light probes we actually are going to work with in the minimal amount of space so that it's as cache friendly as possible, taking up the least amount of bandwidth to the graphics card, blah, 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 blah. We basically want everything to be set up as well as possible to make our lives as easy as possible, because we kind of know it's not one of those things that we're just going to wait for it to be slow. We know it's slow. We know it will be. This is one where you don't have to wonder whether you're doing premature optimization, because guess what? It's slow no matter what you do. And so you have to kind of go into it with a mentality of making sure you set yourself up for success. And in this particular case, we are trying to assign lighting values so that we can put any kind of pre-filter we want at the head end and assign lighting values based on, a separate criteria that maybe doesn't have anything to do with whether or not the entity is active. It might be more about whether the entity is within a certain region specific to lighting that we've enabled, or who knows, right? And so what we need to do now is we need to go ahead and make sure that assignment scheme is relatively safe and robust. We implemented one version of the scheme and it doesn't work. And then we were out of time. And so what we need to do today is go look at that code and find out why. So today is a debugging day. That's what we're going to do. And if I run the application as it stands, you can see us hitting the case here. And like I said, we don't observe any bugs per se. We're not really at the point yet where we would observe an actual bug, because these lighting probe indices aren't used. We were about to use them in the lighting system to figure out how to send down light information to the graphics card, which we now created room for. But we do have assertions in here that tell us whether we think things are working properly. And the place where we actually hit the assertion is in our call, which is supposed to be taking an entity that has no light probe index assigned, and it's going to assign one, potentially, if it's a light probe. It will assign a light probe index to that entity. What we're seeing is that for some reason, the entity already has a light probe index assigned. So you can see if I open up the entity structure here, we're in assign indices, which means it's supposed to check to see if it's a light probe and then assign an index if it is. What we're seeing is that it already has a light probe index, and we have no idea where that came from, right? Now we know which light probe index it is. It's 101. And that brings up an interesting question, which is like, okay, if I run the game again, is it still number 101? It would be great if it was, and it is. So what that tells me is perhaps the way to start looking at this problem is to find out why light probe index 101 got assigned in the first place and why it never got unassigned, right? How are we calling this thing multiple times? So one thing we can see is where is it calling it from, right? You can see in here that ensure region is unpacked. What we're doing is we're unpacking a world chunk. So we're taking this world chunk, we're removing it from the system, we're unpacking the entities, and then we're adding it to the freer list, right? So it can go deal with that, right? That's how we're actually working with this system. Now, the problem is when we actually unpack an entity, right, we're unpacking it into a region. You can see right here, we're unpacking that acquire unpacked entity slot, right? This right here. We're getting back what should be empty entity data as far as the light probe index is concerned. Why do I say that? Because everywhere we were giving up a slot in the past, which I believe is only here, right? So anytime we were doing remove from unpacked, we thought, and obviously we're wrong, we thought we were getting rid of the light probe index attached to that entity. So we're giving up slots here, and you can see when we get to this, where we say like is deleted, remove entities, whatever, you can see it says remove from unpacked here, and remove from unpacked here. These are the only two places, as far as we know, that we can remove entities during the normal game loop, and pack entity, as well as remove indices, will both remove the indices. So pack entity calls remove indices on the entity, right? And you can see remove indices getting called explicitly in the case where the entity is just getting thrown away. So in both cases, it should be the case that the indices got removed from the entity, right? Now, the only other place we know of where we can actually get rid of an entity is where we clear the entire thing. And there, again, we're calling pack entity, which we'll call remove indices. So I'm just not sure, is there some other place, right, where this is happening? Did we miss a case? It's a very complicated piece of code. It's one of the most complicated parts we have in the system, certainly. So, okay, like I can understand that there might be bugs in it. It's intricate and it has a lot of complexity to it. But I just can't think of, at the moment, where we would be having that problem come from, right? So what I'd like to do to start is, since I have a little bit of a clue here, right? I know something. I'm not completely blind about the problem. Since I know that 101 is the specific index that's getting assigned. What I would like to do is I'd like to see when that first gets assigned. So what I would like to do here is basically take and be able to set a breakpoint on this line of code when we have the entity light probe index come back as 101, right? And similarly, I'd like to do that here as well. I'd like to be able to know if we ever undo that one, just so I can kind of see what's happening, right? And one answer could be, and I don't know, but one answer could be that is light probe. For all I know, if we were calling remove indices at some time when the entity had been otherwise destroyed. So for example, if we were calling it, like let's say that here, I don't know if we ever if we even have any time when things get deleted at the moment. Looks like here is the only place, right? So in delete entity, that's the only place. So someone has to call delete entity, and I don't know to what extent that's happening. Let's take a look. So here we delete these two entities, right? These are getting, okay, well, that would probably do it, right? But these aren't light probes, right? There's no light probes on these. So the fact that these are getting deleted and then having their brain ID value set to 0 shouldn't really change anything because, again, they're not actually ever going to probe lighting, as far as I know, right? But yeah, so delete entity maybe should be the thing that removes the indices. I don't know, that's hard to say. But, it certainly could. Hard to say. Anyway, looking at that, it just doesn't seem likely. It doesn't seem like that's the source of the bug. So anyway, moving back here, what I'd like to do is set a breakpoint and assign indices temporarily here. I just want to go in and in here, I want to set a breakpoint on this line, and I want to set a breakpoint on this line. So I just want to see what happens when light probe index 101 is assigned. And so if we look at this entity here, what I would expect to see is type 6 should be a light probe. I don't actually know if it is or not, so we should probably take that and look and see if it really is. This would be 0, 1, 2, 3, 4, 5, 6. So it does look like that's actually true, meaning that brain light probe does seem to actually be correctly set on this. So it does suggest it would have gone into this routine, actually assigned 101 to it, and now we have an entity that is, the entity in question. I can look at value 811. That's kind of interesting too. Probably I should look and see if that's consistent as well, but we'll move on from there. All right. So what you can see is actually this is probably a pretty good sign. So the first time light probe index 101 gets assigned to entity 811, when that happens, we never call remove indices on it, right? So you saw it like it was obvious, right? I come through here, I assign 101. Is it still entity 811? Let's see. So that's a stable value as well. So we assign that index, and we assigned it as normal during the unpack, right? And then the question is just like, okay, what happened, right? How did we then end up assigning it again? Do we exit this successfully? Yes, we do. So we unpacked everybody, and then we're apparently happy about that. And where are we on here? So this is during editing, it looks like, right? So, we're kind of doing our edits here and whatever, right? So at some point, as we kind of come out of here, let's see, we would expect, right, at some point, let me just, let me see if I can, I want to see if we get to this point. So when we go to clear unpacked entity cache, I'm going to set a breakpoint there. Do we get there? So we don't. So we're getting more and more and more information here, right? What that suggests to me is when we go back out here, so this bug is happening entirely inside the world generation. So we're never even getting to the part where we would we're never even getting to the part where we would run the game. Again, that's actually encouraging. That means I had less cases to debug, because now we're just talking about the edit pass. So we're starting to narrow it down a little bit, and that makes me happy, right? I don't want to see this sprawling thing where we have to get 30 frames into the game before the bug appears, right? Because every time you add latency in a bug, it becomes harder to debug. The less stuff that's going on to create the bug, the better, because I just have an easier time tracking it down. It's that simple, right? So that was good. I'm encouraged by the fact that we saw that. But again, I'm not sure how that's happening, right? I don't quite understand how we're ending up with something getting called in assign indices twice, and I think it was getting called in assign indices twice in the same place as well. I'm not 100% sure about that, but I think that's actually true. And so one thing I have to start thinking about is, well, what are the ways in which these entities can really be touched in that sense? And also maybe I need to start looking at just figuring out, like, am I like reducing the size of this array ever in some sense? When I do this packing, we're never calling this by the time the bug hits, so I don't know. So it's something in this loop, I guess, but again, it's pretty hard to say. When you look at what's going on here, when we decide that we're going to remove an entity, you can see us packing here. We romp the entire entity. And that does seem fine. Let's see here. So we have only a couple places where we romp entities. I'm just gonna say, look, when you romp this entity, because you're about to overwrite it, let me just assert that the light probe index is 0 there. And I assume that should fire, but I guess I don't know. And I'm interested to know if it does or if it doesn't, right? And I have no idea. So here's us assigning light probe index 101 to entity 811. And here we are back getting assigned indices called again on a different entity, which is 15. And again, it's got light probe index 101 on it, right? And what you can see here, like if we do this again twice, we're assigning this 151907869, right? That pointer value. If I am to copy that pointer value and just kind of paste it in here, right? So we've got the entity in question. When I hit the bug, you'll notice it's the same pointer, right? So it is 100% a case of reusing a slot without ever calling this part of the function, right? And so we are, at least the manifestation of the bug is exactly what we think is happening, meaning we've got an entity slot, it gets reused without ever calling remove indices. So we're literally just looking for how that slot's getting reused. And so the other thing that I would like to know is, how are we doing like our create entity call, right? And if I look, when we do create entity, like we're calling acquire unpacked entity slot, right? And when we do acquire unpacked entity slot, that's another place, like in here, when I get one of these entities, that's another place I could assert, right? And as you can see, all I'm really doing is I'm just trying to move the bug backwards until I can find it, right? So I'm just trying to look for where these things might be happening, so I can try to fix it. And you'll see me keep doing that as we go. That's not entity, that's results. And so all I'm doing, right, is bubbling the problem up to try and get closer to the source of the error. And so we changed lines, so these have to kind of get reset. There we go. So here we are again on entity, should be 811. Yeah, and it is 101. It is. And now I want to see if we get it, and we do, right? So now we can see clearly, like we're acquiring an unpacked entity slot here, and the way that we do that is always the same. We take the unpacked entity count and we take whatever that last entity was, right? So we're taking that and we're going forwards with it, right? So it's exactly what we thought, and where we're doing this acquire unpacked entity slot here, you can see that we're going to do it, and we're about to go into the part where we fill it out. You can see that somehow we ended up with a slot that, even though we think, right, we think that every time we put one back, it had the light probe index equal to 0. That's what we thought, right? Got it. All right. So I think we found the bug. And what you can see happening here is the bug. These don't get swapped. That's the bug, right? So what's happening here is, in fact, kind of a wider bug. And in fact, we probably want to just fix this more dramatically, I think. Yeah, I think we do. So if you look at what's happening here, when we acquire unpacked entity slot, we're taking whatever the end of the array is and we're using that. But what we did not do, right, is when we actually copy this guy back, we don't clear whatever's in that slot. So the old entity is just sitting there still, the whole thing. Now that's actually fine when we do our unpack because we romp over the data with what we actually decompressed as the entity. But the problem with that is it doesn't actually help us clear out the space for the part that we actually need anew. If we go to create entity and we look at what happens there, you can see us zeroing out the struct because we're creating a new one. That zeroes out the entire struct, which is exactly what we want. However, when we unpack an entity, it is insufficient to simply copy just that part in. We also need to zero the end of it, which is the part that was not saved, right? So when we go to fill unpacked entity right here, that needs to have it taken care of. So what we actually need to do is something more like this, right? Take the destination pointer, add the packed entity size to it, right? And we want to clear the entire entity minus whatever the pack size is that we, actually put in there. We want to clear that overhang, right? And so that will finally get us back to 0, where we know that we haven't left stuff lying around in that other portion, right? So I believe that was probably the bug. Now I don't know, but that was probably it. Looks like I'm wrong. Oh, well, I'm not wrong because that 0 happens after it. So that acquire unpacked entity slot actually can't do that. So let's go ahead over here, acquire unpacked entity slot. So in here, we can't do that just yet because we haven't actually cleared it yet. And we don't necessarily want to because two different people want to clear two different amounts of things. Creating an entity wants to clear the whole thing, whereas just the regular wants to clear just the end, right? Okay. So now we've solved that bug, which was kind of tricky, right? We were thinking of entities as permanent things. They aren't. They're kind of recycled in a way there. And so you can kind of see that we're now back to where we wanted to be, which is we've got light probes. They're getting assigned numbers. Yeah, I think we're all good. Now, what I can do as well is I can play around with this a little bit just to make sure that what we're seeing makes sense. We have a get debug color call. Here it is. And what I'd like to do is I'd like to go ahead and take the part of the code that renders the entities, where it renders the light probe index, where it renders the light probes, sorry. And instead of doing a v4, I'm actually going to do a thing here where we do color equals this. That's what we're actually going to do normally, but I'm going to do one of these here. I'm going to use the light probe index, and then I'm going to delete this. So this way, now we can see that each one of these things is assigned a color. I'm assigned an index, and we could also see if it's stable, right? We could get some sense of whether it is a stable value by whether or not these things are flashing. And what we should see is, although if we went away from something and came back, the colors should have changed, we should never see the colors flash. So while we are looking at a light probe, it should never lose its index. right? And that is what I'm seeing, so that's a good sign. Like, I'm not getting any indication at all really anywhere in here that we're losing the stability of these indices. So that's good, because that means these are stable indexes. That's what I want. And now what I need to do is I need to go and actually start performing some lighting computations with these indices, with these light probes as we go, right? So that's where we're at. All right. So that's all good. Let's go ahead and take a look now at how I'm going to actually go about doing that. We have some things we need to address, such as the light probe clearing and things like that. All right. So here's our situation. We now want to, I guess you can see here where I'm pushing this cube on, right? We know all these light probes are in specific locations, and we need some way of articulating to the lighting system just what locations those are, right? Somebody needs to do that. And we set ourselves up for success, for some definition of success, in the renderer by having, when we output everything, a location where we can record the information about the light probes, right? So you can see in here we've got a max light probe count, a light probe count, a light probe irradiance, right? And the problem that we have here is that this is sort of designed, as you can see, as some kind of a sort of streaming system or something like that. And it's not quite right. There's some issues with it, blah, blah, blah. So what we would rather do here is we would rather have something where we can store information about the lighting that's going on by just recording actual position values into the lighting position array, right? And so unlike other things that want to be cleared every time, this kind of wants to be something that is stationary, right? It wants to be something that just gets updated incrementally and doesn't really have that same sort of streaming quality that the vertex ray and index ray do. So rather than like a count that gets reset every time, we kind of want this to be something more like we're just shifting values in and out and telling you about things that go in and out of the working set, right? So what I'd like to do is kind of change the way this works a little bit. I do need to add an additional array here, which is light probe position. And the light probe position is just one for every light probe, right? But that's all we really need. And then I need ways of setting these up, right? So what I need to do here is I need a call that operates on the render set that basically announces a light probe that it is active and which one it was. So in here we need to say something such as that. I would pass the render group, and then I would say the position of this light probe is this, and that's it, right? I'm not going to tell you what the irradiance is, because I'm going to assume that you cached that. And I'm going to tell you what the position is, because I'm going to hope that you will allow it to move, right? And I'm just promising that I'm not going to move it without clearing it very much. So if there was a slow-moving probe, we maybe wouldn't clear it. We allow it to average. If it teleports, it would be my responsibility to tell you. What that means is we also have a place to put this value, which is here. And we can now undo the lighting probe clear. So we can say, all right, here's the light probe information. I'm telling you if you need to clear the irradiance cache to 0. I'm also telling you if you need to move it somewhere else. And all that will be in one nice little simple function that should allow you to do everything you need to do Render-wise, write it once. The light probe clear only has to happen when the thing moves. And so, yeah, I mean, you know what? Now that I think about it, we could just use a distance metric for this. I'm going to go ahead and say that we probably don't need that light probe clear, now that I'm thinking about it. Because the only reason that a light probe can be wrong is if the light probe moved, right? So the position of it would tell us what we need to know, right? You know what? No. I take that back. So because we do everything centered around a local coordinate system, that's not necessarily true. So I'm going to go ahead and say we're going to leave the light probe clear in there. And I'm going to put a note to that effect so we don't forget. So I'm just putting that in there as a little note because it's pretty subtle. And if you didn't know that, you might think that this would have been sufficient to know whether you should clear it. I don't think it really is sufficient. And so I think that we need the light probe clear. Now, it's true that we could optimize this by doing a positional delta, or rather by using a positional value. So we could look at the entity position that's well, no, I guess we couldn't. So, you know what? I'm just going to stop talking about that. I think it's right. Let's just leave it at that. So I think we're doing that right. I think we do what we need to do there. And I don't want to overthink it. Because, you know, I think I was kind of trying to convince myself of something, but it just wasn't the case. So now what I want to do is in here, I would like to put something that allows us to provide information about these light probes down to the renderer. So we know what it should look like because we wrote the usage code. We happen to know exactly what we want, which is great. And then we can have our clear in here as well. So if you look at what has to happen now, we're going to be getting the commands here. And what we want to do is we want to take a look at the commands that we've got. And first of all, oh, you know what? We forgot one thing, though. I wanted to send down the light probe index. That was the whole point. There we go. So we need that index because this is how we know where it should go. So what I want to do here is I want to say, look, if the commands max light probe count, if the light probe index is less than that, right? If it's not, we want to probably assert that because that would be bad. Assuming we can fit it in here, what we want to do is say if the light probe index is greater than the command's light probe count. Hello. There we go. Or maybe the right way to write this, just so it's a little clearer, is if it's less, right? So basically what we want to do here is say, look, if the light probe index is less, if the light probe count is less than the light probe index plus 1, right? Because it's the count, not an index. Then we want to set it equal to that, right? That's like the new maximum. And the reason for that is as we insert things here, we just want to make sure we have the upper bound of indices so we know when we go to do our lighting, we do it over all the ones that we actually got told about. And we won't do it over any ones that have kind of been shooed out of the set, right? Then what we need to do is into the light probe position array. We now know that we're writing into this specific location. We need to put our p-value. And then if it turns out that we were supposed to clear it, right, we also want the light probe irradiance to be set to nothing, right? So we want to actually clear this light information. We want to clear the light information if you said that the old cached values are now stale, because this doesn't represent the same light probe anymore for whatever reason. Either you assigned a new entity to the same index, or maybe in the future we have teleporting entities, and so if you teleported a light probe, which, you know, I don't know if that's ever really going to happen, but if it did, you would tell us to clear it, because it's like, hey, its lighting value is no longer valid. Even though it's the same light probe, we put it somewhere else, all bets are off, right? So that will announce all of our light probes to the system, and as you can see, if we go back here, that's really all the information we needed, right? The lighting system is going to be responsible for calculating this, and it will preserve it here. And the voxel is created every time, right? We're going to recreate that voxel every time by rasterizing our light sources, our light probes into it, right? And so we pretty much don't really need anything other than that, I don't think, right? Okay. The light occluder streaming, already pretty much done. And so pretty much I think all we need to do now is just focus on getting this part working. And then when we actually have all of this working, we can pop back to the occluder side of things and start to do our ray tracing again, which we have most of the code for, but we need to kind of clean it up and make it work with the new light probe system. All right, so I'm pretty sure that's all we really needed to do to get those light probes into the system. And so now we should be good as far as that's concerned. What is this problem here? To V3 star. Ah. That's right. This is actually like a 6 wide version of that, isn't it? So this clear actually has to clear all 6 of the light probe irradiances. So this is actually more of a this. Right? And that's just because that light probe irradiance is actually for every face of the cube. So when you put down a light probe, you're putting down a light probe that actually has 6 different faces. You know, when I think about that, I also do kind of wonder just a little bit about how that lighting recombination... There are some things I wonder, like, you know, I wonder if it's kind of dumb that we treat the light probes as cubes instead of just, like, points and directions like we were doing before. Because I don't actually know that we couldn't have just done that and then had them just go in a row. I guess it doesn't really matter. I don't know. We'll have to think about that. Anyway, the light probe will get cleared here in you know, kind of an obvious way. And we may want to make this be something a little bit more structured. You know, like we could make this be a pointer to a struct of V3s. The way we would do that would be something more like this. And maybe this is just a better idea. Something like that. And then we could just say, well, you know what? This is a light probe irradiance array, and it just looks like that, right? And that does seem good, because then at that point you're not doing any kind of funny business. You can just say, hey, let's clear that out, and off we go. And that does seem compelling, right? I like that better. And here where we're actually initializing it, then, you know, in the OpenGL layers, if we want to change that, we just could. And because now where we would be putting that information, where is that? Is that in the Win32 OpenGL layer? No, it's right here. So here where we're doing light probe irradiance, instead of the 6 times, we just do light probe irradiance and call it a day, right? So that does seem like a better idea, certainly. If we go over to the lighting system now, we can also take a look and see, does this line up particularly well? If you take a look at the spatial probe here, you can see that the spatial probe in question, which is this right here, you can see that it's just an array of light indices, and it's got the cell dims, right, and the dim pow too. That's just the same stuff. So we should now be able to convert this over, right, to, instead of light index being a thing that we allocate for our, like, for the lighting system, we can actually just use the voxel that's actually present now, right? So we can make these things work right on top of each other in exactly the way that we want and be done with it, right? So I think we're in good shape here to collapse these things down, but, you know, one thing at a time. All right, so now if we run this, we shouldn't get any surprises, hopefully. All we're doing is sending that array down now. And, oh, and I'm wrong. Oh, no, I'm not wrong. I literally said we have to add that to the OpenGL and then didn't do it. So I guess I can't call that a surprise when I said that we had to do it and then didn't do it. So the light probe P just has to go in here. And you can see that I'm using parallel arrays for this, and that's just because I suspect in the future I will need to do graphics card transmission, and I don't want these things intermixed because only some of them will get transmitted. Light probe P won't, light probe irradiance will, or something thereabouts, right? So the light probe P that happens here, all we're doing is just assigning that over. So where the light probe irradiance previously was getting assigned, which is down in here. Oh, in fact, we're already there. We're right on it, right here. This code, when it sets the light probe irradiance, just has to set the light probe position array so that there's actually some place to put those, right? And then we should not get any surprises, or shall I say, if we get anything else, it will be a surprise. Position, there we go. And then we need to do something. We've done all the plumbing work. Now we actually have to do something with it, right? So that's what our next step is. Okay, so taking a look at all of these, you can kind of see, you know, we've got their colors in there, and that's all good. So what we want to do now is we need to start actually sampling from these things somehow. We need to try and figure out a way of getting the light probes down to the graphics card and picking out ones that are close to the pixels that we need. And the way we were going to do that was with a voxel, right? We wanted to have sort of a fairly dense voxel that would allow us to specify how we would pull out our light information and go from there. Now, when I think about it actually, I suppose we do sort of need to transmit light probe position. Sort of. But it's not immediately obvious to me how we're going to do that. We probably need to send down... I mean, just thinking this through, right? It would obviously be much more efficient and easy for us if our light probes were just voxel centered, right? Like, the best possible case for us is light probes just occur in the middle of a voxel, and that's the end of it. And, you know, that makes it easier to do the filtering. It makes it easier to do the transmission, stores less data. But to be completely honest, I'm not sure how that would work with a flexible world layout like ours. So I'm not really sure how, we would be able to get away with something like that. We can pretty trivially use the voxels to pick what we are going to bilinear between, or trilinear between if we use all 8 cubes of the voxel that surround the player or the lighting point. But I just can't quite figure out if I did that. I feel like we just need to store the position still. So I guess I would say I don't really have any ideas here. This is kind of the ugliest part. I'm not really sure what to do about it. We could choose to use a lookup that didn't quite do it this way, meaning a non-voxel, but I just don't know. I don't really see that as being something that's going to be any better. Yeah, I don't really have any good ideas here. I mean, basically the problem is very simple. We want to light with a lighting probe. It would be very easy for us to light with just one lighting probe. Finding the closest probe would be a pretty simple voxel lookup, and we would just light with it. And that's not too bad, right? But the problem we're going to have is that if we only lit with just the closest lighting probe, then we end up with a situation where we will see some lighting pops, because where we change from one probe to another probe, you would see the discontinuous lighting change as you move between them. So the reason that you typically bilinear blend between lighting probes in at least some fashion, or at least linearly blend between at least 2, is because you're trying to prevent that pop from occurring. And I'm trying to think if there's some way of blending these together in such a fashion that it would not require, 8 lighting probes to actually be loaded and then blended per pixel, right? I mean, that just seems brutal. You know what I mean? And furthermore, after you load those 8, you still don't really know what's going on, because the lighting probes have different locations. So you would still have to use, you'd still have to use basically like some kind of positional blend. Yeah, I don't know. This part's a little troubling, and I don't have a lot of good ideas for it. It's a spatial query to find the light probes, and I'm not sure I have a good idea about what to do. Using a voxel is one way to look things up. It would work pretty easily, although maybe would be time consuming because of all the texture lookups, to just look up the 8 voxels that bound where the pixel is that you're lighting, and then do trilinear to find what the actual inbound light is. You could certainly do that, but the problem there that I see is, how do you do the trilinear between things with arbitrary positions? It would actually be a little bit it would actually be a little bit difficult to figure out how you would do that. And maybe, so, okay. So I guess one answer is, even though the lights are not at the centers of the voxel, you could just pretend that they were. Meaning, you don't really care where a light probe is, it's just at the center of a voxel for all intents and purposes. You could do that. The problem with that is if the light probes move, then you end up in a situation where the movement of the light probes creates its own set of discontinuities. Now, maybe the answer is just don't move light probes. Light probes have to stay where they are. And that's probably fine. So maybe the answer is light probes have to stay where they are. We don't really end up caring where a light probe is. We treat the light probe as if it's at the center of the voxel. And that's how we do our blending, and that's pretty much it. And we try to make those two things line up as much as possible, but when they don't, we don't care. That way we can sort of just do one divide. Well, it's not a divide, it's a multiply. We can do one multiply and then take a fractional value, which ends up being the correct amount to blend by, right? In terms of t values for the trilinear blend. And I mean, I guess we just try that first. It sounds crazy to me, but then again, GPUs are incredibly fast these days, so I don't know. Yeah, I don't know. So if you imagine what this would look like, I mean, let's just write it out. Oops. So if we take a look, excuse me, at the Z-bias program, what you can see here is that, well, we're not going to have to change the fragment shader, obviously. I'm sorry, the vertex shader. That can be fine. Also, at this point, I think we may have eliminated the Z-bias as well, so at some point we may be able to get rid of that. I don't know. But if we take a look at the fragment code as we're doing it right now, what you can see is there's a fetch and sum like light thing happening, right? And then we've got like this sum light thing happening and all this stuff. We commented those out because they're not actually happening anymore. But we need to start putting those back in. You know what I'm saying? So basically this right here, where we produce a value that we multiply our surface reflectance by, that needs to reappear. And if we want that to reappear, we've got this lighting disabled thing. We just have to unlighting disabled, and it will come back in, right? So we would delete that. So lighting is no longer disabled. And then what we would do is in here, we have to replace this lighting sum code with code that actually does the lighting fetching that we need it to do. So if you imagine what has to happen per probe is we would need to fetch a probe and the irradiance therefrom, which is 6 irradiance values, which, you know, this is why I say we really want these things to be U32s, because we don't want them to be that big. But so we effectively need to fetch. This is you can see why I'm nervous about this, right? So if we have 6 irradiance values, that means if we fetch 8 probes times 6 irradiance values per probe, times, once they're compressed down, that's 4 bytes, we have to fetch 192 bytes of lighting data for every pixel. Which is not my favorite thing in the world. But I think that's just where we're at. So I think we just start with that, and we then will try to figure out how to optimize it. And maybe we go read some research papers to see what kind of solutions people have come up with here. Because I don't know like what exactly we would do Maybe that's not that much anymore these days. I don't know. But if we were to compute the bandwidth there, like at 1980, at 19, that's good, 1920 by 1080, which is the number of pixels we're going to have to do at a minimum. But we did some work that kind of gets it down to like, not too much above that. Times 192. That's just like kind of ugly. That's 398 megabytes of texture throughput per frame, right? And so, how much text in addition to any texture bandwidth we happen to be using. If we assume the game is trying to run at 60 frames a second, we end up with 23 gigabytes of texture bandwidth being consumed for lighting. Now, granted, we don't consume that much texture bandwidth for any other textures, but, if we were to look at what the texture bandwidth tends to be, which, it's hard to estimate because it depends how often it hits the cache. If I was to go to like a modern 1080 or something, which is like a high-end one, and we look at what the gigabyte per second bandwidth is, right? So like here's some high-end bandwidth would be 320 gigabytes per second in terms of like peak theoretical. And like, yeah, I mean, it's not horrible, but, go down there and look at a crappy card, and you're, like, using the whole thing, right? So it's basically using, like, all of the bandwidth of the graphics card just to load the lighting data at that bandwidth. Now, again, maybe it's not as dire as I'm making it sound, because maybe you hit the cache just so much. Because if you think about what happens, all of the pixels in a given area are going to be loading like the same lighting information, right? So it could be that just you hit the cache so much that you just don't actually take that much bandwidth. So I'm willing to believe that we should just proceed down this road and see how bad it actually is. And then once we are satisfied that it is actually super slow and bad, then worry about it, right? Because I don't know. I can't predict how the graphics card will respond to having to do those texture loads. I just don't know. And so the fact that they'll hit the cache all the time, which I guess they really probably would, I just don't have any insight into whether that means anything. I don't know. So I'm going to go ahead with it for now. And if I think of something magically smart that's better than this, we can put it in there afterward, right? But this is something we may struggle with, because I don't have a particularly good idea of how that would work. All right, so if we move along here, what we would need to do is pretty similar. Like this fetch and sum thing is pretty similar to what we need to do. So beforehand, where we were doing this like running sum thing, when we do the fetch and sum, what we need to do is be able to pass. The difference here is before we were doing like a positional contribution distance sort of thing, and we could still do that. Right? Like, if we wanted to, we could totally still do that. And all that, like, the difference there would... So, I just realized I'm wrong. Actually, we don't have to do what I just said. So what I said was erroneous. For any given pixel, because we are only looking in one direction, so that pixel has a normal, and the normal is the direction in which we will look at the lighting. All we would actually have to do is look at which face of the light probe that is implied by that normal. So actually, it's not true. We don't have to fetch 6 lighting values per probe. We only have to fetch 1. So actually, it's only 8 pieces of lighting data. That's much better. It's not 8 times 6 times 4. It's 8 times 4. I'm sorry. It's it's 8 times 4 times 1928 times 1080, right? And that's a lot more meager. 4 gigabytes a second of total bandwidth if you literally miss the cache every time. Suddenly not as scary as a number, and especially because I do think we will hit the cache a lot of the time. So maybe I'm more optimistic about this than I was previously. Maybe now that I'm thinking about it, it's not as bad, because if you assume that you're only looking at the part of the light probe that you actually need, which I'm not sure why you wouldn't, suddenly that just doesn't seem so bad. Okay. Now, one thing that I don't actually know, it may be the case that we want to separate this out into more samplers than we have. It may be that we want 1 light sampler per direction. So I don't know whether the light probe irradiance is best stored as 6 separate textures, or if it's best stored as 1 texture and we just stridedly access it. The reason I don't know that is because, again, since I'm not a GPU person, I don't know if the GPU is particularly good at doing things like 6 times an index plus 2, right? Intel chips make Swiss cheese of things like this because you can do little tricks, and they have lots of ways of making easy array indices and stuff like that. I don't know to what extent GPUs like that sort of thing. So what I might suggest, and I'm just going out on a limb here, but what I might suggest is that we will actually sort of stride. We will actually have a sampler per light, I guess, per direction. Even that, I'm not sure. Like, I wish I knew more about GPU's internals, which it's just not my thing. Because I'm just not sure. This is simply a case of knowing how GPUs tend to like things. All I really want to know is what's the most efficient way to sample this stuff. And you know what? You know what maybe is the best way to sample this stuff? The best way to sample this stuff might actually just be as a 2D texture, where one dimension is the number of light probes and the other dimension is the direction. That seems pretty good, right? I mean, yet another way to do it would be to do it as a cube map, right? Like, we actually have a cube map, and we literally let the graphics card's cube mapping take the normal and do that work for us, right? So that's another thing we could do, and I guess I don't know, maybe that makes some sense as well, right? The reason that makes some sense is because then it's, on what might be a faster path. Because if the graphics card understands that what we're doing is a cube map sample, it may be more inclined to give us something optimal. Let me just take a look here. Yeah, so you can see here, we could just send these down as cube maps, right? And we would have a special binding for the cube map. Then we just need GLSL and here for cube map samplers. Let me take a look where that happens. So you can see gsampler cube here for cube map textures. I don't know where they, I'm not actually seeing where they actually specify what the GLSL format is for sampling from that cube map, obviously. Let's see. No. Here we go. Oh no, that's just regular protective textures. Never mind. Let's just see if we can look it up this way. Here's the quick reference card in GLSL. Here's the texture samplers, so you can see them on here. And if we're gonna ask it to do a cube map for us, then you can see here, like, there's a special sampler for this. One for cube and one for shadow map cube, I guess. But anyway, so if we take a look at the cube sampler and we do the p-value here, that should, I think, automate the lookup into which one of the sides we're actually talking about. I don't really know if we want to do it this way because it'd be one pixel large, but I'm just thinking about it, and you know, in my head I'm thinking, well, gosh, if we used a cube map, yeah, I mean, I think we probably don't. I mean, it's almost like you think about it, you almost want to use a texture array for this so that you can basically pass the last parameter. And then you more want to use, when you're fetching in there, you would more just want to use like a positional value that you computed. So, yeah, I'm thinking that maybe not. I do think a texture array would make a lot of sense. But I think maybe this makes not so much sense, right? And so if you look at what's happening here, right, where we do a texel fetch into one of these samplers, if we were assuming that actually what we're doing is we're sending down a texture array or a 2D texture or anything like that, that just seems like it makes more sense, because then we just compute the fetch value, we use it, and we're done. So I think maybe we want something more like that, where we have a rectangular texture maybe that we sample from and we're just pulling data out of it. When we want to do an actual fetch, we just do a thing that's like light sampler. We say that the light sampler for our textual fetch is going to be like the light index and the side index, right? Something like this. So we basically pass down which light probe we were asking for and which side of the light probe we were asking for. That gives us back the exact value. The rest of this stuff, we don't care, right? So fetch and sum now kind of becomes a non-issue. And if we wanted to look at what some light would look like, I think we can kind of just get rid of all this, right? And do something more like this. So if we imagined this sort of thing, well, I guess we do need a V4 because eventually we'll use that for intensity. But basically we'd end up doing 8 texel fetches from our indices, right? And the tough thing there is that each index also requires, so it'd be 16 texel fetches total, which isn't great, right? But thankfully 16 is a lot less than what I thought we were going to need, because I thought we were going to need more like um, uh, 8 plus 8 times 6, which is a lot more than 16, right? So yeah. So I think we're looking at something like this. Again, it's not great. You know, I can't pretend that I'm thinking this is fantastic here. But maybe it's the best we can do. You know what I mean? So if we were to fetch our voxel stuff here, right? And I don't know, that may not be. I have to go look at how we should fetch into our voxel. But if we were to come up with these values, so if we were to have a way of getting these indices out of the voxel, which we know we can do, we've done it before, then we fetch based off of them, and we get all of the light data, right? Then it's a simple matter of doing the trilinear blend, and that's actually not so expensive. There isn't a whole lot to it, right? So we know that we would have 3 fractional blending values, and all we really have to do is pick an order of how we want to blend and blend, right? So what I would say is maybe we do lerps this way. So we would combine these 2 values, right? We would combine the z first. You know what I'm saying? So we collapse or you know, maybe that's x first. I don't care how we want to number these. It's completely irrelevant, as long as we make sure that the t values line up. So maybe that's x. So we're gonna collapse the x value first, or the z value first, or who cares, and just get that out of it, right? So we collapse these down. There's the 0, 1. And you know, am I being stupid? Is there already just a trilinear blend? Here, take these values and expand that to a trilinear blend? I actually think there is. But you know what? Let's take a look. Looks like only just the one. You can do it vector-wide, but we don't really want to. I don't think. Because we're not really loading them strided, so I think we're pretty much, we get what we get. But anyway, you know, if we mix this is always this is going to be the t, like, you know, we've got 3 places. We'll call it the tx value, maybe for now. So first we're going to mix along the x, and that's just producing all 4 mixes along the, you know, the x lines of the cube. That leaves us with 4 residual, like, remaining values. We're going to do the same thing again to produce 2 values, right? So now we're blending along y. Oops. Like so. And then finally, we just do the last blend to get the light data that's actually mushed all together. And that just blends the 0 and the 1 via the z. So again, not complicated. That part's really simple. So the mixing, yeah, I'm feeling better about this as I'm actually writing it. Because when I look at it, now that we see how much is involved here, really the 16 textile fetches aren't great. By any stretch of the imagination, but the actual work we then do to light is pretty simple, right? So, you know, this fetching to get smooth blending in 3 dimensions, that's bad and, ouch, certainly. But at least it's pretty straightforward at the end of the day to use it. So I'm not particularly worried at that point about uh, what's going to happen after the fact, right? So yeah. So something like this is all we really need. And if we go down to the lighting code here, you can see where we're doing this. We don't need to do this anymore, so that's kind of gone. Really all we need to do is when we are in here, we need to have actually compiled this shader with or without lighting, right? And I mean, I guess now that I think about it, we always kind of have the lighting setup. So I think we probably want to compile this with and without lighting. And then we just want to know if the lighting's enabled, we use the one with lighting, and if the lighting's not enabled, we don't, right? So I think we want to deal with that later. So that's what we do. In here, we call the SumLight function, and we multiply the surface reflectance by whatever that is that we get out. I think that's all we need, and then we're pretty much done. So really the only thing, so it's a but simple shader. So really the hard parts are just first coming up with which direction we're supposed to look. And in order to do that, we need the normal. Obviously we have the normal because that was something that we're going to be provided. So world normal, right? And world P. We have both of these things, and it's pretty easy for us to figure out what they should be. So what we now need to do is compute those values and then sample out of the voxel based on that piece of information. So in here somewhere, we need like a light sampler, and we need a light index sampler. And this texel fetch here is going to be something that uses the light index sampler. Excuse me. So we're going to say, like, fetch the light index sampler at the light index, and this is going to be, it's like a base index, and this is going to be something where it's got like an X, a Y, and a Z offset, right? So I guess I don't know how texel fetch likes to work. Let me look at how it wants to, because I want to pass integers there, and I don't know if I can bundle integers together in GLSL. It's GLSL. Who the heck knows? So if I go look at texel fetch, it's got like int ivec. So ivec would be what we would use. So I do think we could, right? I do think we could. We could use an ivec here. So I could say, what is this? ivec 3. I could say ivec 3, and I could say that I want it to be like, voxel x, voxel y, voxel z, or something like this, right? And then I just pass that same LOD value because we don't have multiple levels of detail. So in theory, I can do something like this, and then I can get all of the values out of the voxel that I need for blending. Now, of course, like I said, in the voxel, I don't know, like the way that we're actually doing this, these are probably encoded backwards ways, X, Y, and Z, so it probably would look like this. But again, this is just, I don't even know. I don't have any basis. Not being a GPU person, I have no idea what the more reasonable thing would be here. Oops. What happened here? How did I mess this up so badly? We've got like an extra 2 in there. That was weird. All right. Anyway. So, I don't know. That would be what it would be if we actually had the voxel going this way around. Because, of course, the indices are usually switched, inverted from how it's actually stored in memory. Don't ask me why. Well, I guess I know why. Because usually in bitmaps, you go in X runs in the old days. So that's why that convention developed. But, so if we were to do a textile fetch here, we would know what we need. We need a vox X, a vox Y, and a vox Z. And we also need to compute which side we're looking out on. So basically, we're computing where we are in the voxel from P and which side of the light we want via N. And it's pretty easy to know which side we want based on the world N. But the tricky thing is, I don't know what the most efficient way to do that is in OpenGL land. What we want to do is take whatever the maximum component is, and then whether or not it was positive or negative, right? And so I don't know what they've got in here. Like, you know, you can see some things they have that would be relevant there. For doing this, especially because this is a kind of thing that they need for doing cube map lookups as well, right? And so I don't know if there's anything in here that can help us with that. I'm not seeing anything, so we may have to just do it completely manually, which is too bad, right? Because it takes a while to... It takes us several instructions to do. And so I don't actually know if there's maybe something that they had in here that would have been an easier way of producing that integer, but I don't see it, right? Like I'm just... All I see is normal, like regular functions. Shouldn't say normal, that's a little confusing. All I see is regular functions in here. I don't really see anything useful. Yeah. So I don't see anything there. So I might just be missing it. And someone in the chat, if there's a GPU person on the chat, maybe they can fill us in if there is a better way to do that. But basically what we need to do here is compare a bunch of values and pick out which one is the highest value. And I'm not, again, like that's why I say I'm not sure what the best way to have it. I'm not sure what the right way is to get the graphics card to do that series of operations. But basically, it's like, okay, we just want to know whether or not we want the sign to be positive or negative, and whether or not we were larger on X, Y, or Z. So the first thing we could do is say, well, all right, the result is going to be the sign of the X component, right? And so when we or I guess it's even easier than that. It's just the comparison of whether or not it's less than 0. I think sign... Yeah, I don't actually want that. So we just want like this. We just want something like this, right? And I don't know to what extent I can even write question mark syntax. They might not like that. Let me see if they have a ternary operator in here. Yeah, they do. Because I think that's what... Well, I don't know if that's what they're actually trying to say with that, but... Let me take a look. GLSL integer from normal direction. Yeah, I'm not sure. I'm not sure. Anyway, so if we take a look at what's going on here, I'm going to write it out really poorly first, and then we'll try to work on it from there. So then what I would need to do is, and in fact, maybe I just do it with ifs so that we don't have any surprises here. It doesn't really matter. It's not going to be faster one way or the other. So basically what we would do is say, look, it's 0, and we'll just assume that it's 0 if world n x... Oh, and also, I should just use this convention that we introduced already. West, east, south, north, up, down, right? So here are the ways that we want to do this. It's 0 positive, 0 negative, 0 positive. So that's like x negative, x positive. So basically I would say like, look, we're going to assume that it's x negative. If x is greater than 0, then we'll assume that it's x positive, right? Then we'll do, look, if the y component is greater than the x component, then it's actually pointing more in that direction, right? So then what we want to do is say, okay, then we would say if world n, I guess we should say if the absolute value, right? Do I have to say f-abs in GLSL, by the way? I don't actually know. Nope. So then we would say, look, if the magnitude of the normal in the y direction is bigger than the x, then actually we're going to look into that cube instead. So then we just need to know which directions. You know what I could do too? I could probably make this a little bit easier on myself by just... Well, nah, I won't bother. So if the world n is greater than 0... you know what? No, I will. I'm going to do it this way. So I'm going to also track, in addition to my side eye, I'm also going to track a float, which is the max magnitude, right? Or largest component. And so what I'm going to do here is say, all right, the maximum component is x, right? And then what I can do is just say, well, if the max component is less than y, then I'm going to set the max component to be equal to y and set the side eye equal to 2, right? Then I'm going to say if the absolute value of the max component is less than z, then I'm going to set the max component to z and set the side eye equal to 4, right? At that point, I now know that the max component is equal to whatever value was largest. And I also know that the side eye is set to 0, 2, or 4 to tell me which axis is actually the larger one. So then I can just do if the max component is greater than 0, then add 1 to it. Now I have a way to distribute that value, that side value, very quickly, right? And so if I write this a little more compactly here, just so you can kind of see, right, what's going on, it's really just not that many operations, and these will just be selection operations, right? So it's not that bad to select a side eye. That's not too bad, and that will allow us to look up into our texture. So then we just get down to the world position here. And the problem we're going to have here is we need to pass down a bunch of crap. We don't really have a choice. We need to have a quick way of mapping our world P into our voxel. So we're going to have to specify some constants here that have to do with the voxel, right? And what we want to do there is say, okay, the way that the voxel is going to work is that our world P, we're going to subtract like the voxel min corner, right? And this is going to be like voxel relative P, right? Once we have the voxel relative P, We then need to scale it so that it ends up being integer values along the voxel, right? So we then do a vox index p, right? That's going to be the vox rel p times the inv cell dim, right? The inverse voxel cell dimension. That scales us to the size of the voxel that integers are steps of one voxel along. And then we can finally extract all the values we actually need. So we do need floats for tx, ty, and tz. And we then, we also need integer values to be floored out from those indices, right? Now, I don't know how to get an IVEC out of a float. That's like a cast operation, basically, and OpenGL is always a pain in the butt for casting. So while I would normally like a function that's like floor to an integer, right? It doesn't actually have that. So we have to floor and then convert, right? So what we're going to do here is we have to floor, and then I think that's the only syntax, I think. I don't remember how you do casting syntax in OpenGL, but whatever it was stupid. So I think it has to look like that. And so what I want to do now is just say, look, extract these values out as integers. And while you're at it, I also need the fractional value, right? So I need this, right? I also need the fractional value because I need to use that for blending. You know what I mean? So once we compute this, once we compute the lookup for the textures, I also need you to compute the fractional blend values because those are the things that I'm going to use down here, right? I think that's literally the entire thing, right? That produces the entire lighting lookup. Now, at the end, we probably still want to do some work on the actual lighting itself, right? Possibly. I don't actually know. But if you look at what has to happen there, that's basically what we're doing. Now, the thing that's kind of nasty is, I don't know if we want to have to do a three-way blend here to reconstruct as the normal kind of spins around. That's if we want things that are like kind of rounded and whatnot. But I don't know if we ever actually need that, right? We only have flat sprites. We don't have normal maps for them. Maybe we do want that rounded value, or maybe we just don't care. And it's hard to say. But if you look at what would have to happen if we were going to get a rounded value, then again, we end up with we end up with more issues, right? So what I might do is say we probably want to be able to try stuff like that. So I suspect what I will want to do here is something like this. If I go in and I have a fetch, call, and I can basically do the blend to get the light data out. So here. So I can make a fetch call. The fetch call just takes, what you were trying to fetch. That would allow us at any time to do the textile fetch of the... Well, actually, you know what? This can actually be reused too, right? It's only actually that. Be nice if there's a way to bundle that together, but I don't know if I want to go that far. So actually, I take it back. We probably want something that looks more like this. And what you want to do here is be able to pass all of these indices, which is kind of a pain in the butt, right? But you want to reuse them. because you don't actually want to do the fetching again to look up what all the lights actually are. You know what I mean? And so yeah, at that point, it's kind of a bit of a nasty situation. I don't know if maybe, yeah, I don't have a lot of opinions about that. So at that point, you want to be able to fetch more than one side value from your, from your textile fetches. And the problem is you kind of need all of these, right? So you need to be able to do like this. And actually, maybe you just want to do this. You know what I'm saying? So I don't actually know at that point, how ugly this becomes. You can see why I really would prefer to not have to fetch a lot of information. And I also don't know if the cube map... This is again where the cube map stuff comes in. If you imagine something like a cube map array. So you said we have an array of cube maps, and we're going to sample the cube map using this normal, and here's the array index. That's exactly what we're trying to do. So if there's accelerated hardware anywhere to do that, we would want to take advantage of it. And that's why I'm a little hazy, because I just don't know to what extent that exists. Sounds great, doesn't it? Ah, man. That's just slightly different from what we picked. We picked negative then positive, and they picked positive then negative. We should probably switch to using that same scheme, but... So I'm going to go ahead and say, honestly, maybe we just should use this. Who supports this? Let's find out. Let's see who can do this. Magic thing, tell me. It's just me. Like, where are the ads? You know how Google used to have a lot of ads on here? Where do the ads go? I'm getting nervous because if I don't see ads, I'm wondering what's happening. Because I know that's how they make money, and if they're not showing it to me, I think they must be doing something else bad. Like my level of trust is low. But how bad is this? Somebody tell me. I mean, it seems pretty safe. I mean, if Intel HD graphics is doing it, can't be that crazy. You know what I'm saying? 76% is pretty high. I mean, we're already, multi-sample is kind of just assumed to be possible on anything you're going to run a game on, and that's only at 78%, right? So, it seems like we're in pretty good shape there. Let's see. What's something else that's really Durger at this point? Yeah. So, if sRGB is running at 83%, that seems pretty straightforward. That the cube map array is just kind of there. So it kind of feels like maybe that's what we want. It would be a lot simpler, and then we get the sampling. So I don't know if it would blend at that point though. But we could make it blend by copying the values into. So if you imagine, we actually make a 3x3 sort of. So we make the size of the texture 3x3, and then we stuff the values for each face of the cube in there. Maybe that's the best idea. I mean, I want to say that's just what we should do, because then we're on the faster path for sampling cube maps, I think. I hope. And all of the graphics cards will know what we're doing. If I slam this crap down there, it's going to have no idea what's going on, right? So I don't know. So that seems like maybe something I do want to look into. Maybe I want to do something like this, where we look up what the light indices are, right? And then when we actually go get the lighting values, that's just going to be one thing, and we're going to bake the blend in there. And that seems like possibly the right solution. I'm going to say that that's probably good, because again, I'm pretty worried about the expense of all this, and I don't really want to be doing something super weird. So if I can structure this as a thing that just samples cube maps, then that seems like we're not really doing anything weird, and we'll be in good shape. So that means side I doesn't actually have to be computed, right? So this can go away. And what we would really be doing is, rather than calling texel fetch, we would call there it is. We would call sampler cube array. We'd call that, and we'd just call, I think, the texture function, right? And then we would pass the correct set of values there. So then, it's this, right? And so when we call the, it would be gsampler q, it'd be sampler, we would want sampler cube array, right? Is that only in 4? Let's take a look at the 4. Wow, it's a bigger card, isn't it? So it clearly says cube array in here for just the regular texture call, right? And so I'm guessing that basically like we just wouldn't be allowed to do it here because there isn't a 3D cube array version. At least not that I'm seeing. So I'm guessing that this was something that got added after OpenGL 3, which is mildly annoying. But if you look, like I don't really see any indication that you're allowed to do it in actual GL3. I don't know how to tell it we want that extension, right? Like I'm not sure how to actually convince it that that extension would be a good idea. And that we just want it if it's there, right? Yeah, I mean, you can see it's just not contemplated in here, right? You can have a cube sampler, but you can't have a cube array sampler. And that's sort of what we would need. Trying to think if there's anything else fancy. So I suppose there is another way to look at this problem. Entirely. And I suppose that maybe we would want to. And the way that I'm thinking we could look at this instead is if we thought of the lighting more as a texture atlas, where we were actually just going to provide a 2D texture, and then the value that we pass into the sampler just does a bilinear sample on that atlas. That actually seems more sane to me. So bear with me for a second here while I explain what I mean by this, because I realize that's a little bit weird. I really need to get a Milton that has this bug fixed. The strokes look terrible. Does anyone know what the status is of that? There was like a really bad regression in Milton that makes it so that the strokes look horrible, and I don't know how to undo that. Anyway. Or here's all I'm thinking. What if we just have a giant 2D texture? The 2D texture is laid out like this. It is 5 high. It's 5 texels. I mean, look at it. It's horrible now. Milton's just totally messed up now. I should probably try to revert back to the old version, but it's like really bad. So it's 5 high. And then it's light probe count times 3 long. And how it's set up is little chunks of 3x5s, right? Each 3x5 oh wait, I can do this. So each 3x5 is a unwrapped cube. No, that's a 3 by 6. All right. So if you imagined a cube like so, and we unwrapped it such that it basically unwrapped these 4 faces here. I guess now I think about it, I'm probably going to need it to be a little bit wider than 3, but so I've got, here, 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 here. So if I were to number these faces, like I had A, that's B, that's C, that's D on there, then like, E and F or whatever, right? Then down here it would just be like A, right? B, C, D, and then A again. You know what I'm saying? And maybe this is a little conservative, so maybe it needs to be more than what I said. Maybe it needs to be like 6 by 5 might be the right way to do it. But you get the idea, right? So it's something like this. And if you look at where each of these faces is, then the faces on either side of A in this case are like F and E, right? And then for B, right, it's the same. It's F and E. And so you can imagine something where we can just pick a point and get the blend of any face of the cube just by figuring out where we would need to put the point in here to properly sample it. You know what I'm saying? I think that would actually work because no matter where you are in this on here, you should be able to produce the correct blend here, right? And since F and E can't touch each other, they don't ever need to blend, right? And every other every other triple of blending should be related if they touch each other, right? So, like, for example, I know that if I was to take my cube, well, let me draw this a little bit better here. If I was to take my cube and think about all of the places I could be on it, right? It basically amounts to this. It's essentially 8. The entire cube has 8 quadrants, right? They map to 8 octants. They map to each vertex. So each of the whatever normal direction you're pointing, you only really have to map between the outbound values of 3 of the faces, right? And if you look at what each of these are, right, it's going to, and if I number them the same way that I numbered them there, right, so we're just looking at the vertices, there's only 8 places I can be on the cube, right? And those 8 places tell me what my blends are, so let's just walk around them, right? So there's A, E, B as one of them, and in fact, I'll just write them over here. There's A, E, B is one. A, E, D is another. D, E, C. That's DCF. That's BFC. That's BAF. That is DFA. And that is BCE. And that's all the blends that I could possibly want to do. So can I get an AEB? Yes, it's right there, right? So that's fine. Can I get an AED out of it? Yes, that's right there. Can I get a DEC out of it? Yes, that's right there. Can I get a DCF out of it? Yes, that's right there. Can I get a BFC out of it? Yes, that's right there. Can I get a BAF out of it? That's right there. Can I get a DFA out of it? That's right there. Can I get a BCE out of it? Yeah, that's right there. Right? So it does seem possible to do a blend that would create what we want here. And if you always made sure you were inside the triangles, you would get the right blends out. Now, I don't really know how possible that is, because if you think about what should have happened when you were up in here, right? When you're in, like, you know, one of these sections of this cube, you're trying to smoothly blend between the lighting that's coming in at F, the lighting that's coming in at D, and the lighting that's coming in at A. And it's like not... I'm trying to think of what kind of blend that really is, right? It's like a triangulated blend, but I don't have a handle on exactly how, right? But it's an interesting thing. So if you were to imagine creating this kind of a layout, then what you could do is take your input cube values, translate them into a UV lookup into just this one texture, do the texture lookup, and that's the lighting, right? That's the lighting period. So you only do that just one time. So that would get the blend automatically, the directional blend automatically, if we wanted to do that. I just don't know. I'd have to think that through. But we're out of time for today, so that's okay. I'm going to go ahead and just keep lighting disabled for now then. So we didn't finish yet. Yeah. We will pick this back up next weekend or whenever the next schedule... I haven't posted the schedule yet, so whenever the next scheduled stream is. But I'll leave it in a compiling state so we can get back to it. All right, quick questions. Would you want to do a debug Milton stream? Not particularly. I mean, I've never looked at that code base before, so I feel like it's pretty obvious what's going on bug-wise, like because they had an old working version and they updated it, and now it's broken, so it shouldn't be that hard to figure out what the bug is, right? So I'm assuming it's pretty simple. Maybe I'm wrong about that. No questions? Derp Circuit, does this still work on XP? So if you compiled in 32-bit mode, we might be able to still get it to run on XP. The problem is we haven't done that in a while. So there's probably parts of the code right now that would have like casting errors and stuff like that. So I think you would, if you wanted to run it on XP, you'd have to go clean some stuff up first. But it probably wouldn't be impossible if you wanted to run an XP. Because remember, Windows XP didn't really ship a like true 64-bit version. You know what I mean? There was a 64-bit version of XP, but it's not really quite. It's not the same as. It's not really a full 64-bit operating system. It's more like a 32-bit operating system with 64-bit extensions you can use. And so you wouldn't be able to run this on XP without first doing some 32-bit compiles, which would require some cleanup. If you had to draw text in Arabic, Chinese, Korean, etc. in a game, how would you do text shaping? I don't know. So I have not done any work with Arabic. Chinese in particular, I don't think really requires a whole lot of special. I don't get the sense, like, Chinese characters kind of can just be typeset normally, I think. Arabic would be the one that I would think would be more interesting in terms of, like, complexity, but I could be wrong. Anyway, I have not worked on that myself, so I don't have any strong opinions about it. I would want to at least ship one game in Arabic first before I had an opinion about it. So. XXX the Big Fox says, would it make sense to store the whole cube of voxels as 6 3D textures, one for each direction, and then use hardware trilinear filtering? So the reason I'm not doing that is because we're not actually storing color values in the voxel. We could, and maybe we should, right? But right now, what we're actually doing is storing indexes to light probes. The reason for that is because the light probes are kind of large, right? And so, I don't know. Here's the difference in practice, and we can talk about, I mean, you know, it's because, again, storing lights in a voxel may be what we want to do, and I've mentioned that before, so, you know, I'm not ruling that out by any stretch of the imagination. But if you imagine having a 128 by 128 by 2, which is what we have right now, you're talking about going from that to something that's at least that, right? And it's not that bad, right? It's not that bad. So I'm totally willing to believe that we should just do that. And then primarily what we would do, I guess, I mean, I'm not sure, but I think what we would probably want to do is we would basically have the voxel pass be something where we first render into the voxel the lighting. So, you know, we actually have a, like, lighting replacement scheme. That we render the lighting information that we've computed into the voxels. It spams it out. And then we do the texel fetches, right? And maybe that's better, right? Like, I don't know. There's just a lot of complexity here. I don't know which one's better. We could certainly try it. Would you overestimate side F on the cube map? Again, really hard to say. It depends a lot on how we want to try and do that blending. And again, so for example, let's say we do want to go ahead and use we want to, instead of indirecting the cube map, indirecting the voxel, we want to just put the lights in the voxel, right? If we just put the lights in the voxel, then we still have the problem of after we sample, we need to figure out what we do with those samples. And so we would still be back to that problem as well. It's sort of a separate problem, right? Is how do you blend the directions together? All right, I'm going to wind it down. Thank you everyone for joining me for an episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow the series at home, you can always pre-order the game at handmadehero.org. It comes with a source code, so you can play around with it. We also have a Discord if you'd like to chat about the series offline, or while we're online, there's a Pound Live channel as well. Check that out. It's open invite at the moment, so get in while you can. And we'll see you there. I will be back here at some point. We haven't posted the schedule for next week and the coming weeks yet, but we'll post it as soon as I get a chance. So check the schedule on the watch page. Check this right here. We'll be updating that soon. That's it for today. Till next time, have fun programming. I'll see everyone on the internet. Take it easy, everybody.